previous lessons, we've looked at the reason why we have wind, but we still haven't explained why we have wind. We've looked at volume, mass, density, and weight, and then we also looked at hot air going up, becoming less dense. So now let's see, why do we have wind? It still might take another video, but we'll see if we can answer it with this one. So far out in space, you have a flaming sphere that we call the sun. The sun is made up of plasma. That's one of the states of matter that maybe we'll get to at one point. So this big ball of plasma is sending out solar radiation. Radiation is a type of wave, and it's going out through space. Well, it reaches Earth, and because we have an atmosphere, and maybe we'll get into that, we actually can have the heat from the sun formed from the radial waves. So the waves coming off of the sun reach the Earth. But as you can see, and no matter what your crazy uncle says, the Earth is round. Now, since the Earth is round, the rays from the sun reach the Earth at different locations. Where it reaches at the top, which we refer as the poles, that wave has to travel a farther distance than the waves would right here at the center of the Earth, that we call the equator. The equator receives more sunlight than the pole receives. And if that radiation translates through the atmosphere as heat, that would mean that the equator receives more heat than the poles. You know the poles are icy and cold, so keep that in your mind. You might not know about the equator, but think of the rainforests, deserts, places that are extremely hot. They're closer to the equator that receives more radiation and more heat. Well, from our previous lesson, we learned that heat causes air to expand, to become less dense, and it rises. So, hot goes up. And if hot goes up, that would mean that cold would have to go down. So hot air goes up, cold air goes down. Some terms I'll use warm or cool, but it translates the same. And whenever I say hot or cold, we're not talking about 90 degrees versus 30 degrees. We're talking maybe 75 versus 68. It's in relation to each other. One thing is hotter than the other. So the warmer air goes up and the cooler air goes down. Well, next let's think. Does water run uphill or downhill? I think you would assume, and rightly so, that water, let's say this is the hill, water goes downhill. So what's happening there is levels of concentration. There's more water up here than there is down here. And due to gravity, that causes the water to go down. So if you can think water goes downhill, let's think. That's a higher concentration. This is a lower concentration. If hot air expands and is less dense, that would mean that it would have less concentration. And cool air is more compressed and it sinks, it's more concentration. We learned in a previous lesson about density, mass, and weight. So the hot air, since it's expanded, it has less density. The cool air, since it's compressed, has more density. And since we're on Earth, that would mean that hot air is, well, weighs less. And that cold air weighs more. If we can think that water goes downhill, we would think that the cold air, since it's heavier, is going to go down. And the warm air, since it's lighter, is going to go up. Well, in the next video, we'll look at, once again, why we have wind.